Finding the angle between two vectors. So let's say I have vector A and I have vector B, and I would like to know the angle between the two vectors when they start at the same spot. Well, there is a formula for doing this. Let's derive that formula. The first thing I'm going to do is I'm going to add in this third vector here. I'm going to call that vector vector C. Do you see that because of the tip to tail rule, vector B plus vector C, if I start here, vector B, there at the tip of B I put the tail of C, B plus C must be vector A from the very start to the very end. Which means, of course, that vector C, if I move that B to the other side, is just vector A minus vector B. Well, notice in this picture I have a triangle, an oblique triangle, which means the law of sines and the law of cosines apply here. I'm going to write a law of cosine statement for this picture. I'll use A, B, and C to represent the lengths of those three vectors. And in this equation, angle gamma is the angle opposite side C, which in my picture is theta. So I start on the left side with C squared. That would be the length of this vector. Well, that vector is A minus B, so we'd be talking about the length of vector A minus B squared. Then I have the length of vector A being squared, and the length of vector B squared, minus 2, remember these are all lengths in the law of cosines, 2 times the length of vector A times the length of vector B times cosine of the angle opposite side C, which is theta. Remember, I'm trying to find a formula for angle theta. Well, notice that in this equation we've just written down, there are 3 times where I have the magnitude of a vector squared. We have previously learned that the magnitude of a vector squared is equal to that vector dotted with itself, the dot product of the vector and itself. So that means that this expression on the left is just the vector A minus B dotted with another copy of vector A minus B. And then the magnitude of vector A squared, that's just A dot A. Same thing for the magnitude of vector B squared, B dot B. The ending I'll copy down the same. And then look at the left side. It looks like a FOIL problem, and it is. The dot product is a product. It is distributive. And so let's go ahead and FOIL this out. I would have A dot A from the first part. The inner and outer are each going to give me A dot B, so I'll have minus 2 of those, minus 2 A dot B, and then plus B dot B, leaving the right side unchanged. Well, now this works out quite nicely. I have an A dot A I can subtract out on both sides. I have a B dot B I can subtract out on both sides. All I have left now is negative 2 times the dot product of A and B equals negative 2 times the length of A times the length of B times cosine theta. Well, I'm going to get that cosine theta by itself by dividing both sides by what's in front of it. I'll do that on the left as well as on the right. Of course, this side is now just cosine theta. Here, the negative 2's cancel. And so I end up with cosine theta equals this fraction. The top of the fraction is the dot product of the two vectors, and the bottom of the fraction is the product of their magnitudes, of their lengths. Solving this for theta then results in this formula. Theta must therefore be inverse cosine of that ratio. If the cosine ratio is that fraction, then theta, of course, is inverse cosine of the ratio formed with the dot product on top and multiplying the magnitudes on the bottom. we've set out to do what we wanted, which is to come up with a simple formula for finding the angle between two vectors. As long as I know the component forms of the vectors, this is a pretty easy calculation. Find their dot product, find their magnitudes, go to the calculator, I can figure out the angle. The other really great thing about this formula is that it uses the inverse cosine button. Inverse cosine knows angles between 0 and 180 degrees. And those are the angles we would be interested in. So there won't be any sort of strange adjustments needed. This formula will give us exactly what we need. Okay, let's try it out in an example problem. So here's the formula we came up with. Suppose we've got vector A is 2i plus j, vector B is negative 3i plus 2j, and we want to find the angle between those two vectors. Now I could draw a picture, and if you're a visual person, you might find it beneficial for yourself to draw in the two vectors. There's the vector 2i plus j, 2 comma 1, and then let's see, negative 3i plus 2j. That's going to be somewhere like right here. And so we're just talking about the angle between 0 and 180 that runs between those two vectors. So this angle right here, angle theta, is what we're being asked to find. Well, I don't really need to worry about the picture because I have this great formula that tells me exactly what to do. All I have to do is find the cosine inverse of the ratio formed by taking the dot product on the top. Well, let's calculate that. That would be 2 times negative 3, right? Multiply the horizontal components together, plus 1 times 2, multiply the vertical components together. There's the dot product. The bottom, I am going to have to do these magnitudes. Let's see, magnitude of A, square root of horizontal component squared plus vertical component squared, and then I'll do it again. For vector B, I would be squaring the negative 3 and the 2. Let's see, let's clean this up just a little bit and then we can go to the calculator. So the dot product turns out to be negative 6 plus 2, which is negative 4. And then it looks like the one magnitude is square root 5. And the other magnitude, 9 plus 4, would be 13. Let's see, let me clean up one more step. Root 5 times root 13 would be root 65. And so here's what I can go to the calculator with. Cosine inverse negative 4 divided by square root of 65. Arrow out for the parentheses there. I'm in degree mode and I get 119.7 degrees. So the angle between these vectors is about 119.7 degrees. That looks pretty realistic from the picture that we drew. Okay, here's a couple of follow-up questions. Vectors A and B, are they parallel to each other? Are they perpendicular, or are they neither? Well, I hope you can pretty quickly see that they are neither. They're not parallel or perpendicular. Parallel vectors would mean they run along the same direction, either literally the same direction or in the opposite direction, meaning the angle between them would either be 0 degrees or 180 degrees. Perpendicular, obviously the angle between them would be 90 degrees. Well, since I didn't get 0 or 180 or 90, I don't have any special relationship. Now, the last part says, what if I had calculated my dot product? Our dot product was this negative 4. What if I had calculated the dot product and it had come out to be 0? Then in my ratio here, I would have had 0 divided by the product of the magnitudes. But if 0 is on the top, then the whole fraction is equal to 0, and so I would have gotten cosine inverse 0. Well, that's something we should know the answer to. Inverse cosine, let's see, knows about angles from 0 to 180. Cosine tells you the A coordinate on the unit circle. There's only one spot between 0 and 180 that has an A value of 0, and it's right here. So cosine inverse 0 is just 90 degrees. That would mean, of course, that the two vectors would be perpendicular. And that's kind of a famous vector result. If the dot product of two vectors comes out to be 0, you know that they are perpendicular vectors. Thanks for watching.